For today's problem, we need to get a little cinematic, a little scene from an action movie, because after all, it's physics, we've got a little bit of action. So here's the scene. There is a train approaching a bridge on some tracks. So let me get the train real quick. This is how trains look, right? A whole bunch of wheels, cab, thing, whatever, it's like, whatever it is. You know what I think this is how trains used to look? I don't know. Anyway, so here we go. Now, the car behind this engine here, this is an empty boxcar with a length of 5 meters. This train is traveling at a speed of velocity of 20 meters per second, and let's just let that have 2 significant digits. I'm trying to let everything in this problem have 2 significant digits. So there's a train. Chug, 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 chug. You are up on top of this bridge. I draw the rest of it, but it would get a little cluttered. Basically, the train is going to pass under this bridge, and you're the action hero in this movie. Perhaps you're being chased by secret agents. You have to jump into this car as it passes under you. So here's the information you're going to need. You are going to fall a total distance of 15 meters. You are, let's see, let's give this a good, that's not the distance you really need. There. The distance to the near edge of this car is 55 meters. So, just so we are clear, you are 15 meters above the tracks. That train is approaching at 20 meters per second. You need to wait for this car to be in a position for you to jump and land in it. We'll just assume it's carrying pillows or something, because that's a pretty nasty fall. And the near edge of this car is 55 meters away, which means that the far edge would be 55 plus 5, that's 60 meters away. The question is, let me write that in camera. When do you jump? This is a problem that has a range of possible answers. If you jump too soon, you will land on top of the engine and get run over. If you jump too late, you will land on the tracks and splat. There will be a small window in which you can land in the car, work on it, find an answer, and then compare your work to mine. Okay, if you've already worked on your answer, then you're ready to watch this part, because I'm going to do a bit of work. So here's what I need to know. I need to know, how long is it going to take for me to fall? Compare that to, when will that be in that position? So first thing I want to know is, how long of a fall is that? So if you fall 15 meters, that means that it's the distance that you have accelerated from gravity. Going with this equation, the distance I've fallen is 15, the acceleration with which I'm falling is 9.8. That's what we're looking for. So let's just solve that. So 3.06 0.061 equals t squared. Woohoo! I'm going to keep 3 significant digits till the end. That is a 1.75 second fall. There's the work for it. I may have to erase that to make room. Okay, so if I'm going to fall for 1.75 seconds, that means I'm going to need this to only be 1.75 seconds away from where I'm falling. So when will this be only 1.75 seconds away? Well, let's just find out when it will be too late. This 55 meter difference at 20 meters per second, let's fill that in. Well, you know, deltas and average and all that. You will travel this 55 meters in an unknown time if you're traveling at 20 meters per second. Switch those. Time is equal to 55 over 20. Kind of perfect. So if you jump immediately, will be an entire second too early, and then you will die. So let's do this. Wait 1 second. That will be the perfect time for you to land on the front edge. Would not recommend that. That's a little risky. So let me see when would be when you could catch the back of the car. Same equation, but this time we're doing the 55 plus 5. 60 over 20, and that's 3 seconds. Okay, so this 2.75 seconds is how long it would take the train's, the front edge of the car to travel that 55 meters and be underneath you. This 3 seconds is how long it would take the back edge of this car to travel the 55 plus the length of the car and be under you, which means it's going to only give you a 1/4 of a second window that starts at 1 second and ends at 1 1/4. Let me make that super duper clear. The front edge of the car will be under you at 2.75 seconds. The back edge of the car is going to be passing under you at 3.0 seconds. You have to spend 1.75 seconds in the air, which means 1.75 seconds out of this time, you will be falling. So you can wait 2.75 minus 1.75 seconds equals 1.0 seconds for the front edge, or .25 seconds for the back edge. If you jump any time between 1 second and 1 1/4 seconds, I suppose 2 significant digits should really have that